Welcome to the lecture entitled The Demarcation Problem, Falsificationism. I'm Andrew Chapman. In this lecture, we'll cover 7 topics. 1. The demarcation problem. 2. The relationship between demarcation, methodology, and progress. 3. The failure of verificationism. 4. Falsificationism. 5. Falsifiability as the demarcation criterion. 6. The central problem with falsificationism. And 7. The implications of the Quine-Duhem thesis. Before we start the lecture in earnest, I want to tell you the conclusion of the lecture because it's so important, and it contradicts common wisdom about philosophy and science and the philosophy of science. So here is the conclusion of this lecture, and if you learn only one thing from this lecture, it should be this. Falsifiability is not the demarcation criterion. Period. Actually, this is so important, let's change that period to an exclamation point. Oh, why not? Let's just say it again. Falsifiability is not the demarcation criterion. Let me tell you why. Since science can't critically examine itself, that's the job of philosophy, science isn't able to answer what is perhaps the most important question about itself, which is the question, what is science? Answering precisely and adequately the question of what science is requires finding some criterion, some standard or measure or benchmark or threshold that all things that are science meet and that all things that are non-science fail to meet. Such a criterion would demarcate or separate science from non-science. The search for such a demarcation criterion, that is, for a standard that all science meets and that all non-science fails to meet, is at the heart of and is the jumping-off point for the history of philosophy and the history of the philosophy of science, as well as any systematic study of the philosophy of science. The search for a demarcation criterion is known as the demarcation problem. A demarcation criterion separates fields into science and non-science. Things that meet the demarcation criterion are science, and things that fail to meet the demarcation criterion are non-science. Now, there's a particular sort of non-science that's been important in discussions of science and the philosophy of science, and this particular sort of non-science is known as pseudoscience. Pseudoscience is non-science that presents itself as, or pretends to be, or masquerades as science. Of course, not all non-science is pseudoscience. Brushing one's hair is non-science, but since brushing one's hair is not pretending to be science, it isn't pseudoscience. A cloud isn't science, although there is a science that studies clouds known as meteorology, but clouds themselves are not pretending to be science, so they aren't pseudoscience. So all pseudoscience is non-science, but not all non-science is pseudoscience. Why should we care at all about demarcation, about finding a demarcation criterion, about the demarcation problem? Well, of course, there's the abstract academic curiosity of the question, what is science? So if that's something that interests you purely for academic abstract reasons, then you might care about the demarcation problem, finding a demarcation criterion. We also know, though, that science is impossible without philosophy, and that the central philosophical question for science is, what is science? And without a demarcation criterion, we can't answer that question. So since science is impossible without philosophy, you might think it would be very difficult to do science at all if we didn't care about demarcation. Further, science has been unbelievably successful at doing the stuff that science does. If we want to tap into this success, then it would help to know what it is that science is doing that makes science so successful. And we can't figure out what it is that science is doing that's different from other fields if we can't separate science from other fields in order to figure out what it is that science is doing. Non-sciences, attempting to abrogate or steal the good reputation of science, sometimes pretend to be sciences. As we know, these things are called pseudosciences. A demarcation criterion would allow science to keep non-sciences pretending to be sciences in their place. Finally, science has had an unfortunate tendency recently to claim that activities that don't even want to be sciences are in fact sciences, and then to conclude that these activities that, remember, don't want to be science to begin with are very bad sciences. So a demarcation criterion doesn't just keep pseudoscience from pretending to be science, it keeps science from claiming that every field is science. It seems as though there is a general thought that there's something that holds science together, that there's a nature or an essence to science, and that this essential feature of science is what allows science to do what it does and what unifies the different special sciences like biology, chemistry, physics under the umbrella of science. Identifying the nature or essence of science would allow us to do three very important things. It would allow us to separate science from non-science, that's demarcation. It would allow us to figure out what a good scientific methodology was for achieving our scientific goals, that's the search for scientific methodology. And it would allow us to see whether some science is making progress or whether some experiment or course of investigation was progressive scientifically. These are all essentially the same question, even though they come at the question from different angles. The issues of demarcation, methodology, and progress are all ways of asking, essentially, what is science? Verificationism is a family of positions concerning science and philosophy and the relation between the two. Verificationism has both a demarcation criterion and a scientific methodology. The demarcation criterion holds that all and only empirically verifiable sentences are meaningful and scientific, and the scientific methodology holds that science ought to be practiced by attempting to prove hypotheses true using only empirical evidence. Empirical here, of course, means sensory, experiential. Unfortunately for verificationism, it's not only false, but self-undermining. It's self-undermining because the statement of the theory itself contains non-empirical terms such as meaning. And of course, you can't have a theory that relies purely on empiricism or the empirical that then makes use of non-empirical terms. Even further, though, given that empirical data at best only ever serve to make a hypothesis more probable and never to fully confirm or prove that hypothesis true, verification in terms of certainty is impossible. And finally, actual science seems to rule out hypotheses by making claims about what is not going on in the world, rather than trying to find evidence in favor of, or proving, or confirming the truth of hypotheses. Finding evidence in favor of a hypothesis is really easy. Even false hypotheses have substantial evidence in favor of them. Think of any hypothesis you want that you know is false. You can find all sorts of evidence that is consistent with that hypothesis, and so would be evidence in favor of that hypothesis. So scientists don't generally go out into the world and try to prove things true. Instead, they try to rule things out. So setting out to verify hypotheses, that gets scientists nowhere. And this is a good reason to think that not only is verificationism false, self-undermining, misunderstanding the notion of evidence, but it misunderstands what scientists are actually doing out there in the world. Enter Sir Karl Popper. Popper recognized that verificationism has all of the problems that we just talked about. He was a towering figure in the philosophy of science during the 20th century. He's best known for the theory of falsificationism, what we're discussing here. He was also, however, a political philosopher, an epistemologist, a philosopher of arithmetic, and a number of other things. So just what is falsificationism, the doctrine propounded by Popper? Falsificationism is a broad position containing individual theses on demarcation, methodology, progress, and epistemology. Falsificationism is a reaction against and a response to philosophical theses regarding verification and induction, as well as scientific claims, specifically scientific claims in psychology and sociology that were popular during the beginning of the 20th century. So falsificationism is a wide-ranging theory. In 1919, the famous Eddington experiment, which could have falsified Einsteinian theories of relativity, concluded with results that matched Einstein's predictions. So the Eddington experiment, it was a very risky experiment. It could have come back with evidence that showed that there was something wrong with Einstein's predictions. However, it didn't. Popper noted this experiment and used it as a model of good science. Science, he thought, makes risky predictions that could possibly disprove some scientific hypothesis, even if, as was the case with the Eddington experiment, they don't actually end up disproving anything. According to falsificationism, a field is only a science if it makes claims that could possibly be proven false via empirical means. And a claim is only scientific if that claim could possibly be proven false via empirical means. This is falsifiability as the demarcation criterion. This is falsification's way of separating science from non-science. If something is falsifiable, then it's science. If it's not falsifiable, then it's non-science. If it's not falsifiable and it's pretending to be science, then it's pseudoscience. This could possibly be proven false is known as falsifiability. Thus, according to falsificationism, falsifiability is the demarcation criterion between science and non-science. And it's very important here to recognize the difference between three terms that are similar and are often confused with one another: falsifiable, falsified, and false. Something can be falsifiable even if it's actually true. It just has to be possible, that there is possible empirical evidence that if we collected that evidence, if the evidence existed, it would prove the hypothesis, the statement, false. So true things can be falsifiable. Why are we caring about falsifiability? Where does falsification come from precisely? Here's a quotation from Popper. He says, "I found that those of my friends who were admirers of Marx, Freud, and Adler were impressed by a number of points common to these theories, and especially by their apparent explanatory power. These theories appeared to be able to explain practically everything that happened within the fields to which they referred. The study of any of them seemed to have the effect of an intellectual conversion or revelation, opening your eyes to a new truth hidden from those not yet initiated. Once your eyes were thus opened, you saw confirming instances everywhere. The world was full of verifications of the theory. Whatever happened always confirmed it. Thus, its truth appeared manifest, and unbelievers were clearly people who did not want to see the manifest truth, who refused to see it, either because it was against their class interest or because of their repressions, which were still unanalyzed and crying out for treatment." And even further, says Popper, "I may illustrate this by two very different examples of human behavior. That of a man who pushes a child into the water with the intention of drowning it, and that of a man who sacrifices his life in an attempt to save the child. Each of these two cases can be explained with equal ease in Freudian and in Adlerian terms. According to Freud, the first man suffered from repression, say, of some component of his Oedipus complex, while the second man had achieved sublimation. According to Adler, the first man suffered from feelings of inferiority, producing perhaps the need to prove to himself that he dared to commit some crime, and so did the second man, whose need was to prove to himself that he dared to rescue the child. I could not think of any human behavior which could not be interpreted in terms of either theory. It was precisely this fact, that they always fitted, that they were always confirmed, which in the eyes of their admirers constituted the strongest argument in favor of these theories. It began to dawn on me that this apparent strength was in fact their weakness." So, says Popper, if there's no possible evidence that would be against a theory, even if the theory actually does describe reality, then the theory's not scientific. Science makes predictions that could possibly end up being false. The process of falsification itself has a very specific logical form, and it's important for us to understand that very specific logical form in order fully to understand falsifiability and falsificationism more broadly. Each empirically testable hypothesis, call that H, has one or more test implications, call those things I, that would be true if the hypothesis were true. Now, hypotheses can't be tested directly. A hypothesis is just a statement. Hypotheses must be tested via their test implications. If a hypothesis is if an implication is tested and it turns out to be false, then we know that the hypothesis is false. This is a form of logical reasoning that's known as modus tollens, by the way. So just an example here. If my hypothesis is something about the theory of gravity, then a test implication could be that unsupported massive objects will fall. I go out and I test the test implication in order to test my hypothesis. If the test implication came back false, that would show that the hypothesis is false, since the implication has to be true if the hypothesis is true. Now, I'm putting this in these specific terms because we can't understand falsification without it, but we also can't understand what is in fact the central problem with falsification unless we understand the form of falsificationism. So let's turn now to that central problem with falsificationism. Unfortunately, there's a fatal problem with falsificationism. It's impossible ever to falsify any hypothesis with empirical evidence. At first, it seems like there could be empirical evidence that could falsify a hypothesis, but on closer examination of the form of falsification, the form that any possible falsifying instance would have to take, we'll see that falsification is impossible. Pierre Duhem and later W.V.O.Quine noticed that the process of falsification is not as simple as Popper had thought. Hypotheses, noted Duhem and Quine, are never tested in isolation, on their own, but are always tested along with an infinitely large set of auxiliary assumptions, things that are merely assumed for the case of testing, but that aren't argued for in the process of testing itself. What they recognized is now known as confirmation holism, or the Quine-Duhem thesis. Some people call it the Duhem-Quine thesis. Since the set of things tested is infinitely large, it contains the hypothesis as well as infinitely many auxiliary assumptions, falsification can never be completed, even if a test implication turns out to be false. Thus, falsification is impossible. Let me explain this in more detail. To see how the Quine-Duhem thesis works in practice, let's consider an example. Take the hypothesis that acceleration due to gravity changes based on the mass of the object affected. Call that hypothesis H. Now, current science tells us that that hypothesis is false, so this is a good example to use when we're testing whether a hypothesis can possibly be falsified. Now we know that if this hypothesis is true, then we should see objects of different masses accelerating differently based solely on gravity and their different masses. So that is our test implication, the thing that would be true if our hypothesis were true. We check, and the test implication is false. Therefore, our hypothesis must be false, right? Well, not so fast. Hypotheses are never tested in isolation. It's not the case that you can isolate merely one hypothesis. We've also merely assumed each of the following things doesn't affect our test implication. We've merely assumed that the day of the week that we test doesn't affect it, so call that A1. We've assumed that the temperature doesn't affect the implication. Call that A2. We've assumed that the gender of the experimenter doesn't affect the implication. Call that A3. We've assumed that God's will doesn't affect our implication. Call that A4. We've assumed that the shoe color of the experimenter doesn't affect the implication. Call that A5. And you can see there are infinitely many of these auxiliary assumptions. Now, if you're saying to yourself, well, that's just silly, why would any of those things affect the implication? Well, we have no idea, but science doesn't progress by just assuming that silly things or things that we think probably don't affect things definitely don't. Science progresses by questioning everything. And yes, it is true that we need to hold those things fixed, that we need to assume them in order to test. And this is precisely the point that's being made there. So, if our test implication comes back false, as it has here, it might be the hypothesis that's false. But it might be that the hypothesis is true and that A1 is false, one of our assumptions, or maybe another assumption is false, or maybe a different assumption is false, or a different one, or a different one. We have no idea what is false. We can't figure out which one of these things in our infinitely large set is false. And given that the set is infinitely large, we can never falsify any hypothesis given a false test implication. And this is just a result of the logic. The logic says that if the implication is false, something has to be false. Might be the hypothesis, but could be something else. The implications of the Quine-Duhem thesis are that a false test implication shows us that something is false, but that given that the something is in an infinitely large set, we'll never be able to figure out what specific thing is false. If, when looking at the preceding example, it was just obvious to you that it was the hypothesis and not any of our auxiliary assumptions that was false, ask yourself how you think you know that. If it's just by intuition, well, science doesn't progress just by intuition. Science progresses via testing, via experiment, via controlling for anything else that could have made our experiments, our observations go some other way. You don't know via the empirical evidence alone what's false given a false test implication. Now, what this means for us in this lecture in terms of falsificationism is that it's impossible for empirical evidence ever to falsify a hypothesis. Thus, no hypothesis is falsifiable. Now, if the demarcation criterion is falsifiability, that means that there's no science. If something has to be falsifiable in order for it to be science, and nothing is falsifiable, then there's no science. So we have a choice to make. Either falsifiability actually is the demarcation criterion, and science is impossible, or science is possible, and falsifiability is not the demarcation criterion. The latter, that falsifiability is not the demarcation criterion and that science is possible, is clearly the better option here that matches all of our evidence. Therefore, falsifiability is not the demarcation criterion. Now, the fact that Popper was wrong here, that not only is falsifiability not the demarcation criterion between science and non-science, but that falsification is impossible, doesn't mean that everything that Popper said was false and misguided. So if you noticed that a lot of what Popper was saying seems like it matches scientific practice and that it is intuitively plausible, you're right. So we don't need to throw the baby out with the bathwater. Popper was right in his criticisms of verificationism and of naive or simplistic inductivist accounts of scientific methodology, specifically those that came from people like Karl Hempel and Francis Bacon. His epistemological insights regarding confirmation transformed our understanding of scientific knowledge. Further, Popper was right to point to a link between understanding, explanation, and prediction such that we haven't entirely understood or explained some phenomenon unless the theory that we're using to understand and explain has at least some predictive power. Marx, Freud, and Adler all had theories that claimed to explain particular phenomena, but that had no predictive power at all. In fact, most of the time they didn't even try to predict things. They just gave a totalizing worldview into which the evidence could fit, but that didn't seem to tell us anything. Thus, Popper was actually right that a theory that claims to explain everything actually explains nothing. What Popper was wrong about is unfortunately the thing that has become popular in the general consciousness about him, which is falsifiability. In this lecture, we've talked about 7 topics. 1. The demarcation problem. 2. The relationship between demarcation methodology and progress. 3. The failure of verificationism. 4. Falsificationism. 5. Falsifiability as the demarcation criterion. 6. The central problem with falsificationism. And 7. The implications of the Quine-Duhem thesis. Thank you. Actually, why not? One more time. Falsifiability is not the demarcation criterion.